Okay, so I'm just going to do a little lesson about what we did today in class before we take the test tomorrow. So this is covering pages 8 through 13 in your notes packet, so it kind of ends it all. So today, when you look at the PowerPoint, it's going to teach you about independent variables. And independent variables, when you are conducting an experiment, either trying to solve a problem, your independent variable is what is purposely changed. So we gave the example that if you were trying to grow your radish seeds, what's the best way to grow a radish seed? So that's the problem you're trying to solve. So maybe what you purposely change is how much water you're going to give your plants. So you might set up 3 different experiments. One is going to get way more water, one gets a lot less, and one gets 0. And you're tracking it over time. So the independent variable is what you purposely change, and that would be the amount of water. And then we get down to where when you graph your independent variable information, you always put the independent variable on the x-axis. And so when it says, what is the independent variable in the following graphs? It is the baking powder, it is the minutes used per month, it is the air temperature. Okay. Then the next part, like going back to your radish seeds, what's the best way to grow grass seeds or radish seeds? And you want to do different types of water. Well, it's important that you only change one thing. And when you change that one thing, you leave everything else the same. Like maybe the type of dirt, maybe the location where they're getting sunlight, maybe the container, maybe how deep they buried them in the soil. So you want to keep everything else the same. Now your dependent variable is what is going to react due to the independent variable. So it's what you measure. So once again, if we're growing grass seeds and we purposely change the different amounts of water, then what is going to respond to those different types of water? It's going to be the plant growth. So the dependent variable in this example is plant growth. So just giving you a difference between independent variable and dependent variable. Independent variable is what you purposely change, and dependent variable is what you measure. It's what is affected due to the independent variable. Okay. All right, so that's kind of what's going on there. It tells you the independent variable goes on the x-axis, so you're going to circle these. And then the dependent variable always goes on the y-axis. So here's your dependent variable, what you're measuring. Okay. All right, then there's a few questions. There's a scenario in the PowerPoint that I want you to read the scenario and then figure out what is wrong with the experiment and the independent variable. So what is wrong with the experiment? What is the independent variable? And do they have everything that's constant except independent variable? So I'm just going to pull that up really quick. All right. So here is the scenario. Luke was helping his mom make spaghetti for lunch. The water started to boil over the pan, and his mom said she had heard that putting salt in it would stop it from boiling over. They decided to test it. They used 2 pans of equal size. They put 2 cups of water in one pan and 1.5 cups of water and 1/2 cup of salt in the other pan. They found the pan without salt boiled over faster. So the first thing you're going to want to do is figure out what are they purposely changing in this experiment. And they should purposely be changing the salt amount. So you got to be careful not just to say salt, because it's different types of salt, right? So it'd be, what are they purposely changing? It's the salt amount. Okay, do they have everything constant except the independent variable? So this is where you want to think, did they leave everything else the same besides changing the amount of salt? And that's not true either. One got 2 cups of water, the other one got 1.5 cups of water. So having more than one independent variable is a problem. Because at the end, when it boils over, you don't know if it boiled over because there was just too much water in one pot and the other one had less water, or if it boiled over because one had salt and one didn't. So it's really important you only have one independent variable. So what's wrong with the experiment? Well, the amount of water was not the same in both treatments, both experiments. Okay. So you're just answering those questions on page 8 and 9 in your notes packet, these 3. And then I like this slide, just reminds you that independent variable is what you purposely change. And your dependent variable is what you observe, it's what you measure. And then your controlled variable is what you're going to keep the same, and you use that for comparison. And that's up here. All right. Now I kind of just want to go through, after we've done the independent, dependent variable stuff, I just want to go through these data graphs and data charts. So the very first question says, the graph shows a blank growth curve. There's a couple of things on this. You could be putting that it is a positive growth curve. It is a large growth curve. And the other one we were looking for was exponential growth curve. That just means it keeps doubling in a short amount of time. So any of those would work. Then you could go on and answer number 1, B, and C. I think number 2, as long as you recognize this is in the year 2000, this is the people who had the length of their big toe and how it's increased. And then this is what it was in 1900s. Man, what a difference, right? Okay. All right, now this colorful image will be way better to see than what's in your notes packet. We got the male, female, and what percentage of the population in 0 to 4 years of age is in, or what percent of the population is 0 to 4? All right, so if we look at this graph, here's the Mexico population, here's the United States, here's the girl side, this is the boy side. So it says what percentage of the population is between 0 to 4 years of age. Well, here's the age, and it's this first bar. So the male population is 8%, because they're 0 to 8%. And the female population is 0 to 8%. So what percent of the population is between 0 to 4 years in Mexico? You should have got 16%. And you'll do that for the US and so on and so forth. Okay. Pretty sure one of these questions I did not want to do. I think it's further up. All right, let's look at this one. You just got to plug in the numbers. And so when it comes to, in order to estimate the population of geese in northern Wisconsin, ecologists marked 10 geese and then released them back into the population. Over a 6-year period, geese were trapped and their numbers recorded. So total number captured, that'd be these. Total number marked, that'd be this. Total number recaptured with marked. Oh, I'm sorry, the total number marked is the 10 geese. Well, they said originally they did 10. And then the total number with mark, and that'd be this number. So you should be getting this grand total times 10 divided by 6. So use that formula to kind of plug and chug, go from there. Okay. This one, the mushroom plots. Okay, it says, using this plot, a 10 by 10, the ecologist, instead of counting every mushroom in that entire area, she picked 5 spots and counted the mushrooms. And then it says, calculate the number of mushrooms in the forest based on the grid data. Once again, you don't want to count every single spot out of those 100. So she randomly picked 5, counted them, and now let's see if we can use that to figure out an average for the entire area. So we add these numbers, 5 plus 3 plus 2 plus 3 plus 2 is 15. We divide that by 5, which is 3. So on average, there are 3 mushrooms per square. So then how do we apply that to a 10 by 10, 100 square data chart? Well, we're going to take 3 times 10, and on every single one, there's approximately 100. Okay? All right. You got to just keep working through these data tables, and if you get hung up on something, let me know. And then here's that crossword review. And so I think we're probably good to go. Then this extension is extra credit if you decide to do it. But if you get hung up on something, let me know. But that sums it all up. All right. Good luck.